All right, folks, welcome to this special edition of my weather and climate virtual office hours. Today's is a special edition in that it is focused primarily on a region that is not in the Western United States or within California, but is in fact in the Caribbean, where we have one of the strongest Atlantic hurricanes ever recorded, imminently slated to make landfall in the western half of the island nation of Jamaica over the next 18 to 24 hours. It's a very serious situation for that country, and this will likely be the strongest landfalling hurricane ever to be observed on that particular island. And we'll talk about the dynamics of the storm, the geographic and societal context in which this extremely powerful and in some respects already record-breaking hurricane will be affecting multiple countries. It's already been affecting the Dominican Republic and Haiti for several days as it's moved very slowly across the Caribbean Sea amid near-record warm ocean temperatures. It's obviously going to have some devastating impacts in Jamaica, but then also in eastern Cuba, the Bahamas, and then potentially even Bermuda. So unfortunately, far from being what some folks might call a fish storm or a hurricane that might be quite violent but stays out over open waters and thereby not really harming anyone, this is one of those hurricanes that, despite missing continental North America, is actually going to hit quite a few island nations either directly or indirectly and cause quite a bit of harm, unfortunately. But the worst impacts really do appear to be in Jamaica, and then potentially as well in Haiti because of the extreme susceptibility to heavy rain, flooding, and landslides there. So the focus of today's conversation is going to be on Melissa, and I'll have live imagery, including some absolutely astonishing live footage. Won't be live when I broadcast it since it was just published, from the Hurricane Hunter aircraft. Various folks flying in those aircraft today are posting some almost unbelievable footage. It looks like it's something out of a Hollywood movie. Be showing that in just a few minutes. It took some time to curate it because there's so many people viewing these images right now that it's crashing almost all the hurricane tracking websites that I would usually follow. So again, Melissa, the primary focus of today's conversation. I know there are going to be some folks here today who are newcomers who aren't usually here for the California and Western U.S. weather discussion, but there will be many of you here as well. The latter half of the session, maybe the last third of it, will in fact focus on California. Nothing nearly as dramatic going on there. In fact, the conversation is mainly about a rather benign weather pattern, although a different one than we've recently been experiencing. So I will get to that. And then I mentioned this might be a double header, but maybe a more accurate triple header, so stay tuned for a bit of a marathon session. I'll try and keep it not much longer than an hour, but the third segment may talk a little bit more about some federal government updates, as these are late breaking, and some of them are related directly to California weather and even the Hurricane Center hurricane hunting flights that have been so critical in predicting Melissa's path and intensity. So without further ado, I think what I'm going to do, since there's so many visuals to share today, I'm going to start by sharing some of those live visuals while I continue to talk over them. I think that's probably the most engaging way to proceed. Just want to remind folks that this channel is sponsored by Reask, a company that is rethinking extreme weather risk in a warming world, and with whom I actually had quite a few conversations recently about specifically the kind of event we're going to be talking about today, which is a near record or record strength tropical cyclone. A hurricane is a subset of a tropical cyclone, and the potential effects of a rising ceiling on hurricane intensity in a warming world, even if we aren't seeing more hurricanes overall, and how we incorporate that information into predictions and risk estimates that hopefully make us better prepared for what's coming. So just wanted to point out that this is precisely the kinds of conversations that we've been having in recent years. how to manage situations precisely like the one that's unfolding right now in the Caribbean, in Jamaica and other island nations in the Caribbean, and in the Atlantic later on, elsewhere in the Atlantic as well. As I mentioned, Bahamas and Bermuda may be in the path of this as well. So let me share my screen here. You're going to see my infinite mirror first, and then you're going to hopefully momentarily see a live satellite image. So I want to give credit to this pretty amazing website. This is Dr. Levi Cohen's Tropical Tidbits at tropicaltidbits.com. This is satellite imagery that Levi plots and makes available freely on that website, although the underlying data, of course, comes from NOAA, or NASA partnership operating the geostationary Earth orbiting satellites that the U.S. Uses to monitor things like tropical cyclones. Again, this is from the GOES-19 satellite. And obviously, this is not a photographic snapshot in true color of what you'd see from space. The real world is not nearly that psychedelic. But what we do see is right now infrared satellite imagery. So infrared imagery meaning it's using data from the infrared wavelength band. In this case, it's the channel 13 band. That's a bit of, it's a little bit in the weeds. But the point is, this is looking at essentially the temperature of the top of the uppermost cloud layer. So what you're seeing on the right, the units are in fact of units of temperature, units of degrees Celsius. So you can see it ranges from 40 degrees Celsius, which is a very hot day, right? All the way down to minus 80 and minus 90 degrees Celsius. So extremely cold temperatures, like as cold as you'd get at the very coldest periods on the Antarctic ice sheet or something. And keep in mind, we are seeing temperatures like that. So where you see, and I'm going to bring my drawing tool up on the screen here. When you see, I'm going to have to use a different color because we're actually getting a lot of pink on the map right now. So let me choose. Man, we have almost all the colors of the rainbow here. Let me choose. I'm going to go for light blue. Maybe that's the best color here. So you can see in this region, so you have this around the hurricane, you have this nice purple region. Those are where cloud tops are coldest. So where you see the whites and especially the purples and the pinks, those are the coldest cloud tops. You see down the axis down here, but colder than minus 80 degrees Celsius. That's extremely cold, which means, again, this is in the tropics. This is 17 degrees north. Here is the island of Jamaica right here. This is the Tiburon Peninsula in Haiti. This is eastern Cuba, and that is this is just a little chunk of Central America that you can see. So we are right in the middle of the Caribbean Sea. The water temperature in this part of the ocean right now is 85 to 90 degrees Fahrenheit. Think about that for a minute. It's like bathtub water, nearly 90 degrees Fahrenheit. So we have a water temperature that would, if it were measured on this scale, be somewhere up here. In fact, that's kind of what we see where there's no clouds. You're kind of measuring the surface of the water temperature, and we do in fact see those colors up in the 20s and 30s centigrade. So we have bathtub warm water, but the top of the clouds here are minus 80 to minus 90 degrees Celsius. So think about that temperature differential from 20 or 25 degrees Celsius at the surface all the way to minus 80 degrees, minus 90 degrees Fahrenheit at the top of the clouds in this hurricane. That is an indication not just of the extremity of the system in terms of its ability to ingest very dynamically unstable air and shoot it upward to extremely high heights and therefore cold cloud tops. So here the temperature is essentially a proxy for how tall the cloud is. Once you start getting into the whites and pinks and purples, that's rarefied air, literally. That is very high, very cold cloud tops. That means that there's a concentric ring of cloud tops that are just extremely tall, ringing this hurricane. And usually the colder the cloud tops, the deeper the storm, the stronger the storm. So there's a couple of things going on here that I think are of interest. many, many things. What we've got here is a storm that has been undergoing some changes over the last couple hours. So you can see the storm has been moving very slowly. So just keep in mind this box here of just a 1 by 1 by 1 degree latitude by longitude box. It's not moving very quickly, considering that's less than 200 miles on a side. So this is only about 100 by 100 by 100 mile wide box. It has been moving slowly, but not very much. And this is a loop over the past several hours. So it's over the course of several hours moved maybe 50 miles, if not less. So that's think of the miles per hour. 50 miles divided by 3 or 4 hours is not a very fast speed. That's some people could probably outrun the hurricane. Now the problem is, of course, if you were trying to outrun it, would be the 180 odd mile an hour winds you'd be running into. So you'd be literally blown away by winds of that extraordinary magnitude. So the last update, the Hurricane Center confirmed winds of at least 175 miles an hour sustained. That puts it well into Category 5. Again, the Saffir-Simpson Hurricane Intensity Scale is a scale from 1 to 5, where 5 is the highest number. This is well beyond the upper limit. This is well beyond the minimum limit for a Category 5 out of 5. So this is a really monstrous storm, the upper end of the intensity scale, and it appears to have intensified even more since that last Hurricane Center update. The other interesting thing that's going on is this hurricane has essentially moved for the past couple of days very slowly westward to its current position here. So from east to west to where it currently is. The storm is expected to make a sudden and abrupt turn almost immediately back toward Jamaica like this, moving onward towards southeastern Cuba. That is a projection. Now, the storm has not clearly made the turn yet. It's wobbled a little bit to the northwest, but now it's wobbling a little back to the west. A lot of folks online are chattering and saying, "Oh, good news! That means that the storm it's going to miss Jamaica. It's going to continue on this westward path somehow." Unfortunately, that is virtually impossible in the present environment because we now have winds that are rapidly increasing at the steering level that are going to push the storm back in this direction. But it is true that the storm hasn't obviously made the turn yet. And exactly where it makes the turn is going to be really important. Right now, the Hurricane Center forecast assumes the storm is going to do roughly this. That is not good for Jamaica because the storm is not really going to weaken much, if at all, before it does so. But what if the storm takes a slightly more westerly path? Maybe it drifts a little bit further before doing a hook. That's still not great for Jamaica, but it is perhaps a bit better for the most populated part of the country. Kingston, the capital and home to most of the people on the island, is in this part of the country. So in that sense, the farther west, the better. But the problem with that is that there is a substantial population in the western part of the country. Montego Bay is on the north side of the island here. And unfortunately, there's a lot of mountains across the interior of Jamaica in which there are numerous small towns that are extremely vulnerable both to the likely catastrophic flooding that is going to occur as well as high-end tornado-strength winds that could blow down most, if not all, of the forest, the tropical rainforest in this region from this storm. And again, there are communities in there, so that's an extremely dangerous threat. So will the storm continue exactly as on its current path and do a very sharp right hook like this? It may well do so. The Hurricane Center and all of the hurricane models are near unanimous in indicating this is very likely to occur. But exactly where it occurs, the range between, and I'm not drawing an official Hurricane Center cone, but just imagine a range of similar outcomes somewhere bounded by something like this. And this is similar to the Hurricane Center cone. Imagine that the storm goes somewhere in here. None of these are great for Jamaica. But the farther east it goes, the farther on the right side of the cone over here, the more at risk the most highly populated part of the country is, but the more west it goes, the more at risk Montego Bay and a lot of the populated mountainous interior will be here. So there aren't really any good options because it does not appear, even if the storm ends up slightly further west than this forecast. Slightly further west likely means something like this, where it still makes landfall in western Jamaica. There's essentially no indication that the storm is going to end up over here. Unfortunately, you cannot just extrapolate recent motion to understand future motion. Another interesting thing that's going on here, and a little bit alarming, in fact, is that notice what's happened even since I've been talking in the 15 minutes since this live stream began. Look how much more pink there is at the end of the loop where this pauses briefly. So it's pausing at the end of the loop. So in right about now, look how much more pink there is. What does that mean? Well, I was talking about earlier. It means that the cloud tops have gotten even taller, meaning that the storm has potentially trying to grow even stronger with more intense updrafts, more intense thunderstorms ringing the inner core. And just for some general terminology here, the central clear feature at the middle of the storm, that is called the eye. So in the middle of the eye, in a powerful hurricane like this one, the sky may even be clear. It is literally sunny with blue skies in the middle of this incredibly violent storm with winds that are starting to approach 200 miles an hour, one of the strongest storms on Earth. Clear skies in the middle of the eye. In the Eyewall, though, which is the area immediately around the clear sky eye, and I didn't do a very good drawing a circle there, but you get the idea, sort of where the pink clouds are in these concentric bands around the calm eye in the middle. So the term eye of the storm is, well, depending on who's using it, it's been misappropriated or very appropriate. If you refer to the eye of the storm to mean the calm at the center of the storm before you know that eventually the storm is going to pick up again almost immediately, so you have a temporary reprieve, that's the correct way to use the term eye of the storm, meteorologically speaking anyway. It's that it's a temporary, albeit ominous calm because you know what's about to happen next. After having already gone through one of the eye walls, you got to go through the next one. If the term is used to describe the most tumultuous part of an event in life or the storm, it's essentially a meteorological malapropism in the sense that it's not the correct term to describe violent storm conditions. So the eye is the calm part. But the eye wall, though, immediately surrounding it is the part of the storm that is most violent, and that is where the strongest winds are going to occur. One thing that is a small piece, modest piece of good news is that the extent of the hurricane force or the more violent winds like the Category 5, you hear about these 150, 170, 180 mile an hour winds with higher gusts, they are confined to a relatively small area, so a radius something like that in the storm. So once it makes landfall in Jamaica, if it makes landfall in western Jamaica, as appears quite likely, it is possible that Kingston doesn't even see hurricane force winds. They're going to see tropical storm force wind gusts, but not a big problem. But what they are going to see is 20 to 30 plus inches of rain, and that on its own could lead to a completely different catastrophe than the wind damage that we're talking about. The part of the mountainous interior closer to where the Eyewall makes landfall could actually see 40 or 50 inches of rain, depending on how things go. That's, again, a really dire catastrophic flood threat. And the other thing is you can see all these pink and purple splotches sort of in these spiral bands spiraling into the storm. So these are actually cleverly called spiral bands because that's what they look. These are in fact feeding the storm. This is essentially the inflow to the storm, and each of these can be violent tropical rain squalls. So even over, again, I mentioned this is the Tiburon Peninsula in Haiti. This rain squall here, it's very far from the center of the hurricane, but it is associated with it. This could lead to dangerous flash flooding and mudslides in Haiti. In fact, there have already been some deaths reported in the Dominican Republic and Haiti from that, as well as in Jamaica. So there's spiral bands. There's an intensifying hurricane. You can see a clear eye and then a violent wind surrounding the eye wall. The other thing is, just qualitatively, look how quickly this thing is just spinning. to a certain extent, you can see how intense this storm is by the incredible radial velocity of this image. I mean, how often do you animate a satellite image and is it literally dizzying? It's mesmerizing and horrifying all at once. Let's see. Oh yes, and the final thing I want to show is, do you see how this eye, the system, it kind of looks like it's wobbling a little bit. It's kind of doing this. It's been kind of wobbling along since this morning, and you can see its general vector is pretty much east to west, but it has not been a totally linear thing. Well, this is a well-known process in large and intense tropical cyclones known as a trochoidal wobble. So the trochoidal wobble, which is a technical term for essentially for this kind of behavior. So this is a nice little Wikipedia article just showing that the translational direction, in this case just from left to right, whoops, and right to left there, is clearly linearly from left to right. Of the center of this circle is translating at a relatively constant speed left to right, but any given point on the radius of the circle is having this kind of behavior, which is exactly what we're seeing. So the storm is continuing in a pretty consistent direction, but the center of the storm can kind of do this as it does so. That's essentially what we're talking about with these kinds of wobbles. It doesn't mean that the storm has changed direction in any substantive meaning. Now, these wobbles can be consequential, of course, when you get close to landfall, because it really does matter if the point of landfall is here versus here. So we'll be watching these wobbles closely as this hurricane gets closer to landfall, and it could make it landfall further west versus further east. We will see, but I just wanted to illustrate what this looks like for folks. Okay, I'm going to quickly take a look at some comments. And then I'm going to go right back to sharing some imagery because there's a lot more to show today. Welcome to the newcomers. Again, talking about Hurricane Melissa today as the first and primary topic of conversation before I go along and talk about some California weather. I am unfortunately getting a low upload bandwidth warning from YouTube, by the way, so hopefully that doesn't cause any big problems today. So just bear with me. If there are any issues, I will be coming back online. So hopefully this is just a temporary little glitch there. Okay, so what I'd like to do now is I am going to share. Okay, I'm going to take a look at some questions here. I'll come back to the first question later. I think I've addressed the couple of comments about Melissa not turning north yet as predicted. It's true it hasn't happened yet, but it is likely to happen literally within the next few satellite frames. There's very high predictive confidence. Now, is that an absolute guarantee? Well, there is a guarantee it will turn north eventually, but could there be a bit of a westward shift in the point of landfall in Jamaica? That's possible, and it might be beneficial, but we will see. I think it's way too premature for folks saying, oh, it's going to miss Jamaica. There is no indication at this point that that is correct. The National Hurricane Center's point of landfall has barely budged, and they are extremely good, remarkably, almost uncannily good at reading the tea leaves on this. So it is extremely unlikely that this hurricane is going to miss Jamaica, as much as that would be much better for the people of Jamaica. I don't think that's very likely. Yes, there's a comment from Mary that one of the hurricane monitoring airplanes had to leave because the crew was getting quote-unquote banged up inside the plane. I'll talk about that in a moment. I actually have some footage. Talk about the California stuff later on. Thanks, Mary, for the acting as the de facto moderator here. That's always helpful. There's a question from Jose Gallardo about why there's no lightning despite being a very strong and convective tropical storm. I don't know where that impression has come from, but there's been a tremendous amount of lightning in this storm. In fact, there is often not lightning in hurricanes when they're weaker because the clouds are just too warm to get enough charge separation. However, in this case, this storm is so incredibly violent and putting cloud tops up to such incredibly great heights. I mentioned the tops of these clouds are at minus 80, minus 90 degrees Celsius, that there is enough charge separation, and there has been abundant lightning. In fact, there have been bursts of lightning coinciding with the most rapid bursts of intensification of the storm itself, which is something we often see. The Eyewall or lightning is often an indicator of a strengthening tropical cyclone. I may be able to bring up some imagery showing that in a moment. So let me actually see if I can do that right now. While I don't necessarily want to share the screen, but let's see if we can pull this up and see where we can. Okay, so here is the mesoscale sector here, and if we can pull up what I'm hoping to show, I need the other tool for that. Sorry, it's with the government shutdown, a number of tools that would normally be available are not fully accessible. So let me pull this up here. So, all right, so I'm going to pull that up in a moment, and I'll come back to the comments later. So I'm going to start sharing my screen again so folks can see it. Okay, I'm going to close some tabs so I don't crash the computer. Okay, so here is an alternate view of the hurricane here. Let me do a few more images here so it's a slightly longer loop. Okay, so the problem here is there is a little bit too much. All right, let's superimpose that on top. So here's the lightning, by the way. So you can see that right in the eyewall of Melissa. Again, here's Jamaica. Here's the eyewall of Melissa. There's continuous lightning. In fact, there's a burst of it right now, which is indicative of some strengthening. You can see that there's actually more lightning in these spiral bands, as I mentioned, that are feeding into the hurricane all the way out hundreds of miles away. But there is, in fact, lightning right within the eyewall of Melissa. Let me see if I can, that's what I need. So what I need to show here, just bear with me. Yeah, so here's the actual view of what this hurricane looks like from space, by the way. So if you are in the International Space Station, and I suspect there are some astronauts right now looking down with their fancy cameras, taking the snapshot, if I add an overlay, I'm going to add the lightning as an overlay to this map. Okay, there you see it. So this is what I wanted to point out. Yes, I know it's large data. Let me just let this load for a second so I don't crash anything. We still don't have the IT infrastructure, by the way, built for extreme events in the 21st century. And whenever anything big happens, everything just crashes. Despite the jerkiness of the image, you get the idea. This is the eyewall of Melissa, and you can see I'm going to toggle the overlay on and off for a moment. You can see the abundant lightning that is. Oh no! Whoops! I just changed the overlay here. You can see the abundant. No, I don't want that. All right, let me close a couple things. There we go. Okay. If I toggle this off, you can see the eye, where the eye is, which is a really stunning image. Toggle back on, you see there's plenty of lightning. So you get the idea. All right, while I'm on here, and then I'm going to close this because it's going to crash my computer otherwise, let me just zoom in. It is amazing, despite technical glitches, that we can see this live. This is a live image. The last frame was taken, let's see. The last frame here was taken 10 minutes ago. So this is live from space with just a 10-minute time lag. Look at that eye. It is pretty just ominous. And you can see, as I mentioned, you can see the surface of the ocean through the eye. Do you see that dark patch at the middle here? That's the ocean. So the sky is clear in the middle of the storm. And I'll talk a little bit about the dynamics of how that's possible later. All right, so I'm going to close that so I don't crash anything. Here's the more stable tropical tidbits version. I'm going to update this, refresh the page to make sure that it's actually live here. Unfortunately, it does look like there's been a burst of strengthening in the half hour since this live session has begun. Here, courtesy of Polar Weather website, which is always a funny name for a website that does a great job tracking hurricanes, but here we are. Here is the trajectory of the storm. So this is a classic, what's known as main development region storm. It came from the central Atlantic. It propagated almost west-northwestward, and then it did this weird track where it meandered for days in this region. It produced a lot of rain and flooding over Hispaniola, and then sort of started to make a beeline westward before rapidly intensifying into one of the strongest hurricanes on record in this part of the basin in recent hours, and is suddenly going to do this right hook. Again, we have, this hurricane. Obviously, Jamaica's here, where it's going to be either probably Category 5 at landfall, maybe Category 4, but ultimately it really isn't going to matter, unfortunately. This is a really dangerous hurricane landfall either way. Then going to make another major hurricane landfall in eastern Cuba, probably a Category 3 storm landfall in Cuba after it does a bit of weakening over Jamaica's mountains. It will weaken a bit further as it accelerates out over the Bahamas, but this is still a strong Category 2 storm that will cause damage in the Bahamas, and then could it go on to affect Bermuda in a few days from now. Granted, more as a Category 1 storm, which Bermuda can probably weather pretty readily. So again, the main threat is Jamaica from a direct Category 4 or 5 hurricane strike, which they've not seen before, a direct hit from a hurricane of this strength, and also residual threat to Haiti in particular from heavy rainfall, and then of course eastern Cuba from a major hurricane landfall, and in the Bahamas. So this is sort of where we have been, where we are now, where we're headed with this. Here is a topographical map of the island and nation of Jamaica, and I want to point out a few things here. I did have to brush up a little bit on my Jamaican geography. But Kingston, the capital and home to a majority of people who live on the island, is roughly here. So that is the capital city, and the greatest population density is generally in this part of the country. You may also notice that the highest mountains in the country are over here as well. And these mountains are nearly 7,000 feet tall, so they are true mountains. There are some significant mountains as well in the interior of the island, though, in the central and western part of the island here as well. And unfortunately, this is the region that is likely to be devastated, or most devastated, by this storm, because it's going to see Category 4 or 5 winds, as well as 20 to 40 inches of rainfall. Montego Bay is over here, which is one of the other island major population centers. This, again, based on a storm that is likely to take a trajectory across the island of something like that, that means that the winds on this side of the island are most likely to be from this direction, and the winds on this side of the island are likely to be from the south and east. So what this means is that the winds are going to blow upslope from the ocean up these mountains. And the wind gusts in these mountains, because of that, because they're several thousand feet tall, are likely to be even higher than the surface gusts. So when we have the hurricane hunting aircraft have been measuring wind speeds of essentially 200 miles an hour at above the surface of the ocean and in some gusts. Those are the kinds of gusts that are conceivable if this hurricane does not weaken substantially, and it is not expected to. In some of the upper mountain areas, there could actually be gusts to around 200 miles an hour. That is a level of wind speed that even well-constructed buildings could potentially be destroyed, multi-story buildings that are well-constructed. So that's a real concern here, is that even with higher-level engineering construction standards, which most new buildings in Jamaica are actually built to, because this is an island with a long history of hurricanes, and Jamaicans know that they're going to see more of them in the future. That has been a consideration in building on the island. But the problem with 200-mile-an-hour wind gusts, which you could see at higher elevation points. Now, the only good news is that there's no major population centers up in the mountains, but there are a lot of small communities that could be devastated and, quite frankly, isolated for days or weeks to come. It is quite likely that the island's telecommunication and electrical infrastructure will be largely destroyed west of Kingston, and there will be major issues even in the capital region. But in this part of the island, which again is most of the island, not necessarily home to most of its population, but obviously most of the landmass and plenty of small towns and a couple of mid-sized cities. There is a city called Mandeville of about 50,000 up in the plateau region. This could ultimately be one of the largest population centers to see the strongest winds and heaviest rain, by the way, from this event. So that's of major concern here. This is not a good direction for a storm to be hitting the island from, because it means that the winds are going to be blowing upslope. So think of atmospheric rivers in California. What happens when those strong winds blowing moist air move upslope? Well, it's upslope by definition, because you got to go from sea level here to the mountains here. This is why there's going to be so much concern over flooding. These mountains are going to intercept massive volumes of rain, and also the high mountains down here will. Even though the storm's going to be over here, there's still going to likely be 20 or 30 inches of additional rainfall over here. The slopes are very steep. The slopes above the Kingston capital region itself are steep as well. Catastrophic and widespread flooding and mudslides possible over the entire island, as well as Haiti to the east and then Cuba eventually. So that is a major, major, major concern. This is the official advisory. Let me refresh to make sure it's up to date. This is the most recent key messages from Hurricane Melissa. And I'm just going to read this. This is from the National Hurricane Center, which again is a U.S.-based, NOAA-based entity. And I'm going to talk a little bit more about what it means that the government is shut down right now. Obviously, the folks at NOAA are still here working on an emergency operational basis. But let me just point out the kinds of language and the kinds of forecasts that the U.S. is providing for this. In Jamaica, the message at this point is, quote, remain in your safe shelter and do not venture outside. Catastrophic, life-threatening flash flooding and numerous landslides are expected through Tuesday. The Eyewall's destructive winds may cause total structural failure, particularly in the higher elevations, leading to widespread infrastructural damage, prolonged power and communication outages, and isolated communities along the southern coast. Life-threatening storm surge and damaging waves are anticipated. That's pretty consistent, unfortunately, with some of the specific impacts that I was just discussing with the topographical map discussion. And then as well, in Haiti and the Dominican Republic, catastrophic and life-threatening flash flooding and landslides are expected, particularly across southwestern Haiti and southern portions of the Dominican Republic through midweek. In Haiti, extensive infrastructural damage and isolation of communities is likely. And then in eastern Cuba, heavy rainfall with life-threatening and potentially catastrophic flash flooding and landslides is expected to begin. So this is not boilerplate language, I guess, is what I want to point out here. This is language that the National Hurricane Center only uses under dire circumstances, particularly the language relating to Jamaica, and that is commensurate with the situation at hand. Okay, so I'm going to take another look at this satellite image. We'll just to keep an eye on it. I'm going to answer a few more questions, check on the stream, and then I have some pretty amazing footage from the Hurricane Hunter aircraft to share with you all. So let me just switch back over. You'll see me again answering some questions live. Take a sip of tea. It's getting a little cold. Okay. As a question from Brian Wynn, what are the chances of an eyeball replacement? I'm assuming that's just an autocorrect of eyewall replacement prior to landfall. It is Halloween week, I suppose. Is it in the realm of possibility that we watch intensification in real time? So, what is an eyewall replacement cycle? Well, storms go, tropical storms, as particularly stronger hurricanes, go through episodic, essentially changes in their internal structure, where an eyewall replacement cycle is when an existing eyewall, remember the eyewall is not the calm eye in the middle, but the eye walls where the most intense winds and rain and the tallest clouds are, the most violent part of the storm, and that concentric circle around the eye, that eye can be replaced by a broader eye wall. So essentially due to various processes, including the conservation of angular momentum, as a storm spins up, its eye contracts into smaller and smaller. So think of a figure skater who holds their arms out and then spins slowly and then slowly spins faster and faster and faster as their arms come together. That's a dramatic example of the effects of conservation of angular momentum. The very same thing is true for hurricanes, and it's also very dramatic when it happens. It's not a subtle thing. It's a pretty dramatic increase in the rate of rotational velocity, and that can spin up the winds. But as that happens, it can cause instabilities in the storm, and sometimes what will then happen is the large amount of kinetic energy in the storm as the storm spins up and the eye gets smaller and smaller and smaller and the peak winds get higher and higher and higher, as we've been seeing. The eyewall replacement is when that just becomes an unstable configuration, and essentially the storm wants to reset itself a little bit and sets a new eye wall. Essentially you have double eye walls or even triple eye walls in some cases out radially from the center of the storm. And as that happens, as a secondary eyewall develops, what will often then happen during an eyewall replacement cycle is the larger outer eyewall will become the dominant one and the inner one will suddenly, or not so suddenly, dissipate. Meaning that now you may actually have a slightly reduced maximum wind speed because now it's like the figure skater who's spinning rapidly with arms against their chest and then they start to move their arms outward to slow down again, increasing their effective radius. But the problem then is even though the peak winds come down a little bit, the total amount of kinetic energy is roughly the same, and so now what you've got are slightly lower peak winds over a narrower region, but now they're over a broader area because the eye wall is broader. So could there be an eye wall replacement cycle now or before landfall in Jamaica later tonight or tomorrow morning? That's certainly possible. It's not really clear it would be good news at this point because it might bring the winds down from 180 miles an hour to 160 miles an hour. Still devastating winds, but it might actually affect 50 or 80 or 100% more land area. So the trade-off would be slightly lower peak winds but over a much broader area, which given the trajectory of this storm with a landfall likely in western Cuba, it would not be a good thing if the winds were slightly lower but distributed over a larger area, because the only real saving grace I can see right now is that the Kingston area seems unlikely to get the brunt of the strongest winds. But the more the radius of winds increases with the potential eyewall replacement cycle, the more likely it is that those much stronger winds would affect a lot more people. I'll talk a little bit more about the dynamics of hurricanes in a minute. So just for folks referencing, this session is a bit of a doubleheader. It's likely to go a little bit long today since I'm trying to cover a lot. I will get to the California weather portion a little bit later. And if you have to go, as always, these sessions will be recorded. So you can always come back after I push stop and look at whichever part of the live stream you were most interested in. Otherwise, I might separate these into two different sessions, but this week has been a little bit crazy. And by a little bit, I mean very difficult to manage time this month, and so trying to cram it all into one. So thanks for your continued attention as I take a sip of lukewarm tea. Okay, a few more questions here. Mary mentions that keep in mind that the NOAA Hurricane Hunter planes, and again, there are both Air Force and NOAA personnel who are involved with the Hurricane Hunter flights. These are essentially reconnaissance aircraft that are flown directly into or on top of, depending on the type of aircraft, some of the most violent storms on Earth to gain critical information that's unattainable in any other way at the present time about the internal structure of these storms. It's very critical toward making good hurricane predictions, which is why we do it. It's not zero risk, so there has to be a pretty large benefit for the U.S. government to continue to do this, and for people who are on these aircraft to put themselves potentially in harm's way. And it turns out that the cost-benefit ratio, even in that context, is still very high. The benefit to cost ratio is quite high. So there is a tremendous benefit that we get from these, call them in situ, so in place observations that you cannot get unless you fly directly into the hurricane. And on that front, this is a good opportunity I think, for me to share the footage. So I have some footage from folks who are on those aircraft, and I want to show that in just a minute here. And so I'll take a break and show that now. Let me make sure I share the screen so I'm not just talking over it. Okay, so apology. This is from X. This is the only place I can get these in real time. And I'm going to there's a little bit of a background drone from the engines. You can see these are turboprop aircraft. They do not fly jets into the storms like this for a variety of safety-related reasons. I'm going to mute the sound on the video because it's just that drone of the turboprops. But just let me orient folks. This is the eye of the hurricane. That you can see the ocean. You can see ocean waves down there. Do you see the waves in the ocean? So currently, this is footage from the aircraft that is orbiting within the eye. There's the blue skies in the upper left. There's the ocean churning, and you can see the violent rotation of the winds clearly apparent in this footage. It is genuinely remarkable, and I'm realizing this video is actually playing only from 2 minutes through. So let me go back to the beginning. So, and what I'm actually going to do is, let's see what happens if I do picture in picture. Nope. So I'm going to go without my drawing tool for this one. I'm just going to annotate with the mouse, with the cursor, since you're seeing my screen share. So there's the eye. There's like a quarter circle of the eye up here. So this aircraft, this hurricane hunter aircraft, is orbiting within the eye. This is called the stadium effect. So you can see this sloping upward feature of the inner wall. I'm going to play it forward now. I'm going to mute it again. You can see this sloping feature. That is the eye. This is the eye wall, and the edge of the eye wall as it descends into the eye of the storm. And you can see that there's, again, blue sky and this roughly circular feature above. And if this camera points down, as it does later in the video, you'll see the churning ocean below. But this is a sign of a very mature and powerful hurricane. If you can see this clear blue sky eye, and I'll explain a little bit as to how that comes about in the first place. But your plane is going to bank, and you're going to see as they're orbiting to stay out of the eye wall. They're giving themselves a bit of a break to do some sampling in the calmer conditions in the middle of the eye. I'm going to zoom forward a little bit since this is a similar picture. Okay, so the panning down, there's a few clouds in the eye in some parts of it, but you can see in between the clouds is the ocean, and clearly these are very different clouds. See the upward vertical development of the thunderstorm clouds. This is the eye wall, right where this cursor is on the left, and they're doing a turn, a sharp turn. By the way, the eye is very small. It's only 10 or so miles wide, so they're essentially doing a continuous 45-degree bank or something like that. So this is a much steeper bank than you're going to get on a typical commercial aircraft. So again, the stadium effect. Here is now you're looking directly across at the other eye wall on the far side of the storm. So the eye is below you. They're orbiting in a circular fashion around the eye. This is the eye wall. These are the clouds that are so tall that despite being in the tropics, the top of this cloud is at minus 90 degrees Fahrenheit or minus 85 degrees Fahrenheit. So they're so tall that they're reaching up into the part of the atmosphere that is colder than minus 80 degrees. Again, really just astonishing. And there you can see there's the clearest pocket. There are the ocean waves. So you see these little white specked region here. Those are the massive 20, 30, 40-foot ocean waves and the white caps on top of them. And as you can see, this remarkable orbiting. But there's another video too, and okay, well, maybe I just should have started with this one. I buried the lead here a bit. So you're going to see this is as they're in the eye wall here. This is the first frame. It's all white on purpose, and then look what happens as they punch out from being in the eye wall into the eye. That's how dramatic it is. Wow. Wow. I that's all I gotta say. This is one of the more remarkable. So there's the eye from the inside of it. There's almost the full semicircle. This is probably the best evidence of the stadium effect I've ever seen. So the stadium effect, it's because you think of like the sloped ascending seats of a stadium. That's essentially what the edge, the edge of the eye wall looks like here. Wow, this is really just remarkable footage. Again, this was published just about 45 minutes ago on social media by folks who were in the aircraft on this incredible pass through. And normally I would, for the sake of time, I'm skipping around a little bit. But you can see, the upward motion in this eye wall, the cloudiness. You can literally see the clouds rising up in this image as the plane approaches. And again, they are the hurricane hunters, so their goal, they got to fly back into this violent updraft of the eye wall. So it's calm right now. Well, okay, they're going to bank. I guess they're still orbiting. They're trying to decide which part of the eye wall to enter. So they need to enter the eye wall at a place that is reasonably safe, because in a Category 5 high-end hurricane, you can get updrafts that can threaten the structural integrity of the airframe. So they're deliberately flying into the kind of updrafts that are greatly more violent than the kinds of updrafts that commercial airliners are going to avoid at all costs. So they're flying directly into an updraft. You can see, look how violent that upward moving air is. The second it moves in here, you obviously lose your orientation. Just remarkable stuff, truly remarkable stuff. I'm going to bring the live satellite image back up. Again, this is Melissa, and I'm going to start talking about a few other things. So this is Jamaica. Since I've been talking, again, more pink means colder cloud tops. That northward turn has not happened yet. So this, it's a little bit interesting, right? This is one case where it would be amazingly beneficial for people if this storm somehow managed to miss Jamaica entirely, even though there's, again, no indication that's going to happen. Even though the motion has been like this, there's every indication that there is going to be, in a matter of minutes to a couple of hours, a sudden north and then northeastward turn back toward Jamaica. It's amazing we can make that forecast with models, because you certainly wouldn't assume so with any sort of reasonable extrapolation. But that is what meteorology, what the laws of physics tell us has to happen eventually. But the laws of physics can't tell us whether that's going to happen here versus here. So that is why we have that cone of uncertainty. But unfortunately, it still does look like it's going to happen somewhere in the western half, maybe more likely the western third of Jamaica with this little westward shift. But a little bit of hurricane meteorology. I'm just going to use this map as a template. So imagine this is a cross section of a hurricane. So I'm going to draw a little bit on the left side here. So imagine this is, say, the western eye wall of the hurricane. So you have some tall tropical thunderstorm clouds with rain and lightning here. And then let's call this the eastern eye wall of the hurricane, as we just saw in that video from the hurricane hunters. More rain here. So what we've got here, as we saw in those videos, is upward motion in the eye wall. Again, this is a cross section. What we then have, though, in the middle of the hurricane is very strong downward motion, known as subsidence. This is why the air inside the eye is calmer, drier, and warmer, because you essentially have compressional heating. Think of downslope or offshore winds during a Santa Ana wind event in California. Downward moving air is drier air. So what we actually have with Melissa is, earlier today, the driest air ever observed in the eye of a hurricane was observed with Melissa earlier today in this region. So literally the driest air we've ever seen in the center of a hurricane. And what we then see is this return flow into the hurricane. So we have this vertical circulation in the hurricane. So essentially within this structure, in the western eyewall, we have the upward movement, we have some horizontal movement toward the eye, and then we have downward motion in the eye. And the same thing happens eastern eyewall, upward motion, inward, and then down, because it has to go somewhere. And it can't go, in this case, it can't go up because the tropopause is forcing sort of a hard upper limit, a lid on things in the atmosphere. So what can't go up anymore then must come down, because you have air converging in this region, and to not violate the continuity equation, conservation of mass, it can't just continue to accumulate indefinitely. So you do have high pressure here aloft. You have low pressure at the surface, because obviously this is diverging, and that's why we have low pressure at the center of a hurricane. So this is the sort of the three-dimensional structure, cross-section of a hurricane, and we're seeing this unfold in real time, unfortunately. Okay, I want to take a few more comments as we get toward the hour. As I mentioned, it's going to go a little long, but it's okay with me if it's okay with you. So I'm going to take some more hurricane-related questions now. Then what I'm going to do is I'm going to jump to California, talk about that for a bit, take those questions, and then do one final check of what's going on with Melissa at the end of the conversation. As some folks have pointed out, the people in the hurricane hunting aircraft are not getting paid because the government is shut down, but they are considered, and I think rightfully, essential workers. But because of the DOJ-related firings from earlier in the year, the hurricane hunting staff is down in the NOAA branch, AMOL in Florida, that essentially is coordinating these, is down by 40 to 50% staffing, so they've been desperate. I'm hearing through sources who wish to remain anonymous that they are desperately calling up the personal landline phone number from retirees from the hurricane hunting program and former meteorologists who are coordinating and in some cases going on these flights. So imagine telling somebody that they need to come out of retirement to hop on to one of these aircraft to fly directly into one of the strongest storms ever observed in the Atlantic Basin. And oh, by the way, we're not going to pay anybody anything because the government is shut down indefinitely. This is a problem throughout the federal workforce, of course, where the vast majority of the federal workforce is currently furloughed without pay, meaning they're not allowed to work. But the people who are working without pay and without a break, and with increasing workforce attenuation. So not only are people working for no pay, and almost everybody in the federal government has now missed at least one paycheck, but these are people who are literally flying into the most dangerous storms on Earth in the middle of the night. Last night, earlier today, I guess it was, one of the hurricane aircraft missions was aborted early because the turbulence was so extreme that they were concerned about the structural integrity of the aircraft and obviously therefore the safety of the people on board. So understandably, that particular mission was just considered to be too dangerous. And again, these are not folks who are at all going to say no to a challenge, even under pretty extreme situation. They're quite used to G-forces in the updrafts and downdrafts that would make even the most seasoned commercial air pilots queasy. Certainly the typical passenger. There are, of course, a fair number of retired Air Force folks who are not retired, or former Air Force folks who work in commercial air travel these days as pilots. They might have had some experience with this from the old days. But even here, I mean, even if you're flying a fighter jet or something, you're generally not trying to fly into the most violent updrafts you can find on Earth, as these aircraft are. And it is dangerous. They have a good track record of safety for many decades. If you read Dr. Jeff Masters' book or watch his any of the interviews he's done on this, there was one hurricane hunting escapade, let's call it, in Hurricane Hugo some years ago, where they did come fairly close to losing an aircraft due to the violent updrafts. They were not quite sure how they were going to make it out of the center of the storm. A partially disabled aircraft, they were able to make it into the eye and start orbiting it, but they didn't have enough engine power to go up and over, and they realized that they were going to have to go right back through the Eyewall with an aircraft that was not fully functional. Harrowing story. They did all obviously make it out, but last night there was an incident where one of the aircraft had to leave abort the mission because they were concerned that something like that could happen again. Fortunately, it did not, but it's just an indication that this is public sector work that is very much in the public interest, very much essential work, where folks are doing something that is objectively dangerous and they're not getting paid at all right now. So just for some perspective on some of the real world impacts of both the shutdown, which as it drags on indefinitely, but also the broader workforce attenuation we're seeing through DOGE, through forced or coerced early retirements, things like that. I do have one other thing to add to that a little bit later, but I just did want to point that out because I do think it's an important consideration here, and it has been the case, whether or not the NOAA PR folks are going to admit it right now. I am hearing from internally that they are having significant difficulty staffing these kinds of missions right now because a lot of the people who would be on them were fired or forced into retirement earlier this year, and so they are literally calling people at their retirement addresses, their personal phone lines during a shutdown, and asking them to come in and help with the situation. That is what I'm hearing. Anyway, I'm not a journalist, so unfortunately I can't validate all those claims in real time, but based on everything else that's gone on recently, I have no reason to doubt those kinds of anecdotes right now. And I will point out that it was specifically something that was mentioned as a concern prior to hurricane season with the destaffing of these agencies, that precisely that might happen. Now it's happening, by the way. All right. There's a question, how much of an impact can this hurricane have on a warmer climate? Well, it's an interesting question of the effect that a hurricane would have on climate. Generally, any one storm isn't going to affect climate so much, although in general, tropical cyclones, hurricanes included, are a great way for the Earth to redistribute heat and energy. So hurricanes are essentially a way of drawing lots of accumulated stored energy, including the additional accumulation of stored energy in the oceans due to climate warming or global warming over time, and draw it out of the ocean, put it into the atmosphere, and then move it toward the poles. So hurricanes are heat engines, essentially, quite literally, in fact, heat engines that draw energy, their energy from warm oceans, and then redistribute that energy poleward in the atmosphere. So they are, as you might expect, increasingly capable engines as the climate gets warmer. We are seeing quite a number of rapidly intensifying and overall very intense hurricanes in recent years. In fact, there have only been 5 hurricanes in the Atlantic this year, which is actually a fairly low number, but 4 of the 5 of them have reached at least Category 4 out of 5 status. I think that's the highest ratio of hurricanes attaining that extremely high level of intensity that we've ever seen. It's a remarkable number. And what it means is that even if we aren't seeing more hurricanes, the odds that a hurricane that does develop goes to reach these upper echelons of extreme Category 3, 4, 5 intensity is increasing. We see that all throughout the world, and we see that in the Atlantic Basin in particular. So the clearest signal between a warming climate and hurricanes is A, with more extreme tropical rainfall and worse flooding. We've seen that unambiguously case after case after case. B, with higher storm surges than you would have seen otherwise, simply because, well, as sea levels rise, the storm surge magnitude can increase, even if the storms themselves don't change. And then number 3, yes, we are seeing more intense hurricanes, not more hurricanes. We are not, so far as I can tell, we're not seeing more hurricanes. And we're also not seeing more hurricanes this year. This year has been a below average number of hurricanes in the Atlantic Basin. However, the ones that have occurred have broken records for their exceptional intensity, and that is not a coincidence. It is because The atmospheric conditions for initial development of hurricanes have been kind of unfavorable, but the oceans have been so damn warm that whenever there is an occasional condition where the atmosphere becomes a bit more favorable, they take off like gangbusters and they attain these exceptional levels of intensity. So this is another you could call it another whiplash process in a warming world, by the way, hurricane intensity whiplash, where we might see about the same number or perhaps even fewer global hurricanes overall, but the ones that do occur are already becoming more intense, producing stronger winds, lower pressures, heavier rainfall, everything that we would not want to see with a hurricane. And Melissa is an example of a hurricane that has taken advantage of near record warm ocean water. And again, warm ocean water is hurricane fuel. It is the primary source for the energy that hurricanes become the heat engines to dissipate. So to argue that warming oceans don't affect hurricane intensity just defies basic physics. It really is something you just can't get around. It's a fundamental thermodynamic reality. It does not necessarily mean that there are more hurricanes. And don't be fooled by folks who claim that the lack of an increase in the number of hurricanes or the number of hurricane landfalls is a number that is misleading, because what we really care about are how many hurricanes are achieving this extreme intensity, because we know that the higher the intensity of the storm or the more the rain it can produce through heavier rainfall, more water, more flooding, the more destructive potential it has. That's all I'll get to on the global warming side of things today, since I've already bitten off a little more than we can manage in an hour. But thanks for sticking around. In fact, I see that there are more people online now than even in the first hour, so I am going to keep going, answering some more questions here. Jump over to California weather, and then briefly jump back to Melissa at the end. Hopefully that answers Noah's question from earlier as well. All right, here, let's see. Sorry, the questions just jumped. There's a comment that the hurricane hunters found a 240 flight level wind. I'm assuming that's 240. I don't know if that's knots or miles an hour. At some point, that's just a ludicrous number. I mean, 240 mile an hour winds is, granted, even commercial jet aircraft will fly through the jet stream sometimes when the jet stream can reach 200 miles an hour. But that's a much more laminar, smooth flow. So in this case, that's a very turbulent wind. So that's not a just wind parallel to the flight vector, but that's a wind that might be angled upward or downward, and your plane is going to be pitching all around. So unlike flying through the jet stream at a nice, relatively smooth, cool, cozy 200 miles an hour, this is a very turbulent up and down. And so the stresses and the g-forces you're going to get flying through 200 mile an hour winds, a very different story. That's just an incredible number. And as several people have pointed out, those flight level winds, normally you get weaker winds at the surface because of friction. But in this case, because the storm is going to hit the mountains at near peak intensity, you can get almost those kind of flight level winds manifesting at the surface near mountaintops. And there are people who live there. There are forests there. So I really think, unfortunately, this is going to be a complete destruction of the power infrastructure, major defoliation, if not major forest blowdown, where the trees aren't just defoliated of leaves and branches, but they may just be toppled en masse with loss of forest in the long run, depending on how things go. We've seen this on Puerto Rico. We've seen this with Category 5 landfalls in Florida, in the Big Bend region, where there's a lot of forest, and the south there. We've seen this in other regions. In Mexico with hurricane, I forget I'm blanking on the name of it, near Acapulco last year. So we can see, when you get these 150 mile an hour winds in a forest, obviously it's very hard for any tree to survive winds of that magnitude. And so when it occurs in a narrow swath from a tornado or a brief wind gust, it's a localized destruction. But when you have a Hurricane Eyewall that's going to cut across a 10, 20, 30, 40 mile wide swath, you can see widespread defoliation and devastation of the forest. And that's obviously, people live in this forest. There's power infrastructure and commercial infrastructure in this forest. This is not a remote region in the sense that, it's a place where nobody lives. People do live interspersed with the trees in the forest here, and that could cause some really big problems. And again, the number one threat is probably still the extreme risk, really the risk of catastrophic widespread floods and mudslides. And unfortunately, that's where the most substantial death toll is likely to come from. But this is a relatively rare case where extreme wind damage, including complete destruction of even well-built structures and of forests, is possible. A question from, I'm not sure who it's from Mike, about there's discussion of the toroidal wobble earlier, so if you missed it, you can go back later. Do models account for this phenomena? They can exist in a model. Generally, I'm not a hurricane expert, actually. There are those who specialize in tropical cyclones much more than I do. Generally, some of the high-resolution hurricane models can represent toroidal wobbles, but generally speaking, I don't think they're well predicted because they're kind of stochastic and random. So they might exist in a model, but they're going to be, whether or not they're present in a particular model, prediction is kind of not based on the actual initial conditions on the ground. It's kind of random. So they are often unpredictable. And this is one reason why even a few hours before landfall, we can never pinpoint exactly where a hurricane is going to make landfall, because it could always do one of these toroidal wobbles at the last minute and shift 20, 30, 50 miles in one direction or the other. And it can be quite consequential. It can be either better than expected news or much worse than expected news. And this is one reason why you have to issue evacuations across a broader region than the ones you're certain are actually going to be impacted because of these wobbles. It matters very much whether you're 50 miles from a hurricane Eyewall or 100 miles. 100 miles away, you might not even have to deal with much wind. If you're within 50 miles, though, in this case, you could get 100, 130, 150 mile-an-hour wind gusts. So it's the difference between, a quite manageable tropical storm and just truly violent winds. So it's a consequential difference that we can't just always suss out in advance. Apparently this is a featured live stream on YouTube right now, which would explain the newcomers. So again, thanks for joining. I'm going to continue talking. I'm going to pull or shift to California weather for a moment and come back to Melissa in a moment. But for those who have joined today, welcome. I do offer a wide range of perspectives on weather and climate, sometimes in real time, and I do have semi-regular live streams, usually at least once a week or so. Right now, my schedule is a bit erratic, but generally pretty regularly. If you do want to be notified when these occur, please do remember to not only to subscribe to the channel, but maybe more importantly for folks who've missed it, turn notifications for live streams on. Otherwise, you won't get that automatic notification. Yes, and as Pam points out, I am grateful for the support of the University of California Agriculture and Natural Resources, my primary employer, for their support in allowing me to continue to have these live sessions. It's a heavy lift sometimes, but I am glad that this is part of what I get to do as part of my job, which is kind of amazing when you think about it. All right. So let me pull up some more. Well, actually, in a slightly less catastrophic vein, again, for those who are just joining, I'm going to come back to Melissa in a moment, but I'm going to pop over to California weather for just a few minutes here. In a much less consequential moment for California weather than for weather in the Caribbean and in Jamaica, there is some light rain recently across Northern California. It's been dry in Southern California, but the main thing I wanted to talk about was the likely emergence of a much warmer and drier pattern for California in the coming days. I gotta switch over to the imagery here. So again, I'll go back. Here's where we are right now. We see some emerging weak ridging over California, so high pressure aloft. That's likely to strengthen going into early November before we see a pretty strong ridge centered over right around Las Vegas, it looks like, so the interior southwest by the first weekend in November. It might not be too warm come Halloween, so, relatively mild, but nothing to write home about. It might get pretty hot, though, thereafter. Next weekend in Southern California, the desert southwest, 80s and even some 90s returning. So that's some pretty hot weather for November. Nothing record-breaking necessarily, since we do tend to get some autumn heat waves, late season heat waves, but it is well above average for November. The key point is that in general, the ridgier pattern looks like it's going to stick around for a while, and for some reason I'm having some slow internet. Oops. Well, let me see what's going on here. So I think Tropical Tidbits just went down, the website I'm using for California weather data, because of the hurricane. Not as a direct causal response, but probably because Levi's site is now overwhelmed. So, okay, I'm going to pivot a little bit. So talking about the potential for some ridging developing, much warmer temperatures, drier conditions in California. Since I can't show the model data right now, what I do want to show is, once again, we have this marine heat wave stretching all the way from China and Japan, as I've been talking about all summer, all the way to the California coast. That persists. There's been a bit of cooling in the Gulf of Alaska, but again, there's still a lot of anomalously warm water here. Also, incidentally, look at the Caribbean. The whole Caribbean is 2 to 3 degrees centigrade, so as much as 3 to 5 degrees Fahrenheit, warmer than average. That's hurricane fuel near Jamaica. But for the California context, we have this long band of elevated water temperatures in the Pacific Ocean here. Then we also have this elongated band of cooler than average ocean temperatures on the map in the eastern tropical Pacific. So this is the developing La Nina signature, so cooler than average temperatures in the eastern tropics. Then we have this nice warm blob of water in the western tropics. So what we got is this horseshoe pattern of warmth. Now, this horseshoe pattern of warmth in recent years has coincided with a lot of ridge patterns in the atmosphere over the west coast. Not exclusively, but it has been more than a coincidence. This year, the seasonal outlook, thanks to the combination of this La Nina combined with this warm North Pacific Ocean, combined with something that's known as the easterly phase of something that sounds incredibly technical and in fact is the easterly phase of the quasi-biennial oscillation, or the QBO. I don't talk about it too often because often it's a little bit beyond even my pay grade. It takes place, it's essentially a pattern that describes east to west variations in winds in the stratosphere, so the level of the atmosphere above where the weather is usually taking place. These are the factors I think that are going to be in play the next few months into winter. But in the short term, it looks like it's going to be, especially in Southern California and the interior west, warmer and drier than average. Let's see if Tropical Tidbits is coming back. No, it is not. That's still down, so I'm going to keep that down. What have we seen recently? So here's the accumulated precipitation. This map is courtesy of climatetoolbox.org. This is, again, for the last 30 days, so this is from essentially late September into early October. We see some, thankfully, much-needed rain in the desert southwest, although we did see flooding in central Arizona, along with some severe thunderstorms. We saw historic rainfall in southwest Colorado, including some major flooding with rain well in excess of the top of the scale of 5 inches here. But what I really wanted to point out here is that most of California got a nice soaking over the past month. And this includes parts of the state that don't normally see a lot of water this time of year. So sometimes along the north coast, yeah, October can be a wet month. And yeah, we've got 4 or 5 inches of rain up Del Norte County up in the north coast. So, but we've also gotten quite substantive precipitation along the entire Sierra chain. So from the southern to northern Sierra, everywhere in the mountains have gotten at least 2 to 3 inches of liquid equivalent. That's a pretty solid early season soaking up in the mountains. So essentially, in this part of the state, I would say people have been asking about fire season. There's a difference between saying fires are biochemically impossible, which is not true, and saying that in this region that I'm sort of drawing the hash marking within, fire season is, for all intents and purposes, over in terms of consequential fires that I would personally be concerned about if I lived there. It's not to say that you couldn't get a grass fire still if it's warm, dry, and windy, as it may be at times, but in general, it's just too damp. There's just been too much moisture, and it's likely that this part of the state will see at least a little bit of additional moisture over the next couple of weeks. So I think the hash-marked region here, fire season is pretty definitively over with. And that is good news because it was not a particularly bad fire season in these regions. And I think that means we've officially made it out of fire season in these regions more or less relatively unscathed. Now, from the Bay Area to the Central Coast, that's still pretty good moisture for September and October. So we're still talking about fairly widespread 1/2 inch to 2 inch totals. In the pockets that are closer to 1/2 inch, I think fire season's probably not over. We could still see some fires, but this is still putting us in a better situation than we would normally be in this time of year. So fire season is not over, but the consequential fires are probably over, even with a fairly extended warm and dry period. But you might still see grass fires, etc. By the way, really everywhere in California from here north, during dry periods over the next few weeks, we're going to see some great conditions for prescribed burning, risk-reducing, ecologically minded burning, taking advantage of these windows where vegetation, in particular grasses, they'll dry out a bit, but the deeper fuels, the logs and the forest floor, the accumulated biomass, that's still going to have some residual moisture that's going to keep it, in some cases, from burning too intensely, but it'll be dry enough and sunny enough and breezy enough to get some good combustion going where you want it to. So expect to see prescribed fire applied extensively in this region. In fact, you can check out the Watch Duty app. You're going to see tons of icons, green fire icons, noting that we are indeed seeing lots of prescribed fire happening. Now, there's a more interesting question about Southern California. So the transverse ranges, again, have seen some significant rainfall. There have been debris flows, thunderstorms, heavy rain. It's a bit more of a patchwork, but a lot of this region has seen significant rainfall from about 1 to 3 or 1 to 4 inches. That's substantial. Less down here, though. In San Diego, Orange counties, there's been a little bit of rain, but mostly under 1/2 inch. So what am I thinking about fire season in Southern California? Well, I think the short answer is it isn't over yet. And that is in great contrast to most of the rest of the state. I think we're pretty much done up in here. Fire season, consequential fire season is over. Prescribed fire season is now, hopefully, I hope, in full swing. It may also be prescribed fire season in Southern California, but there is overlap with a fire season that remains. Fire season where we've gotten a couple inches of rain is very much attenuated for now. But with upcoming weather, temperatures in the 80s and 90s with the potential for some offshore winds and no significant precipitation in the forecast for the southern third of California, we will likely see a re-emergence of fire season in November and December until we get another couple episodes of widespread soaking rain. And they do not appear to be favored because this winter, this part of the Southwest is likely to end up drier than average. So we're likely to see a persistence or perhaps even a re-intensification of drought in this region due to low precipitation this winter. In this middle band, it's really difficult to tell. There's really no strong predictive signal, and that does include most of Northern California and the Sierra. So drier down here this winter, And then maybe as we get up into the Pacific Northwest, maybe opposite, because La Nina is going to favor some wet conditions up in, which is good news for coastal Oregon and Washington, where they're having some drought up in this region. So the seasonal outlook looks pretty different if you're up here versus here versus Southern California and the interior West. This means, though, that we may well see significant fires reemerge. If we get a strong offshore wind event, expect to see fire weather watches and red flag warnings issued down here. However, up here, we've gotten enough vegetation moisture going that I think that's much less likely. Now, to be clear, because I know a lot of folks in Southern California experienced some legitimate trauma earlier this year with the catastrophic fires in January of 2025, we do not have the same conditions in place right now that we did this time last year, leading up to the catastrophic fires in LA. Even though fire season is not over and dangerous fires could recur under strong wind conditions, we do not have the same record-breaking level of vegetation dryness that we did last October and November and December leading up to the fires. And essentially, I can guarantee you that we won't have that through December because already we have too much moisture in place right now with what's already fallen with 100% certainty to get to that point. But we could dry out to seasonal levels. We could even dry out to drier than average levels in coastal Southern California. And that is why right now the risk is pretty low, but we shouldn't necessarily assume fire season is over. In fact, I would be fairly surprised if we didn't see at least one more episode of significant fire weather somewhere in coastal Southern California in the next 1 to 2 months. Hopefully by December, January, late December, January, we get more significant rain that more definitively shuts down fire season. But unless or until that happens, things are going to be drying out with fairly hot weather into the 80s and 90s again, and some offshore breezes. That's going to dry things out. And we have not yet seen enough rain in Southern California to end fire season, but we probably have up in Northern California. Okay, finally, the last thing I wanted to mention. There's a story in the San Francisco Chronicle today by Anthony Edwards, now one of the newsroom meteorologists at the San Francisco Chronicle. I correspond with Anthony pretty frequently and did so for this story. One thing we talked about in this story was about how essentially cuts to NOAA and the Weather Service are having significant effects on weather prediction in California. And one thing I suggested to the Chronicle team was to take a look at the forecast discussions, these technical documents that are issued by each local National Weather Service office, in this case, the Sacramento office, which has been understaffed to the point, along with the office in San Joaquin Valley, which serves it's based in Hanford and serves both the San Joaquin Valley and the Southern Sierra. And the Sacramento office serves, of course, the Sacramento Valley and also the Northern Sierra and the surrounding foothills. They're not operating, they're not staffed at night. They do not have meteorologists on staff 24 hours a day anymore since the funding cuts occurred earlier this year. And I think the proof is really in the pudding. Here with this data visualization, the number of forecast discussions issued was pretty stable for a number of years, and then just sort of went off a cliff in earlier this year, beginning in February with what some have called the Valentine's Day massacre, with the firing all these federal employees. And again, this is good, consistent with good data visualization practice. This axis does go all the way to 0. So this is actually a large change, a large decrease in the number of forecast discussions issued. The change would be even more dramatic if you looked at the length of those forecast discussions. So how many words or characters? Now, is the Weather Service in Sacramento and the San Joaquin Valley still providing critical life-saving services? Of course. But they're doing so in a diminished capacity through no fault of any of the people who work there, but through the fault of those who would seek to defund NOAA and the Weather Service. And we're starting to see more tangible, quantifiable impacts like this. We haven't had an exceptionally consequential weather event in the Sacramento area of responsibility since this occurred, so we've done okay. But what happens here, and as is detailed in the story, we may be going down to a point where we no longer have, during a major flood event, we may only get one flood update per day. So if an atmospheric river is causing major flooding somewhere in California, the staffing at the California Nevada River Forecast Center, or the CNRFC, which is co-located with the Weather Service in Sacramento, they do not have adequate staffing levels this year to have more than one update cycle per day. And some of the quotes from meteorologists, anonymized, again, due to, I think, quite legitimate fear of retribution, that this could be a really big problem. So I encourage folks, anyway, to read this article, because it is really, this is the first time I've seen this quantitatively demonstrated. And it's just but one small piece of an enterprise that is under extreme stress, as are so many aspects of the federal government right now. So many public servants working. By the way, these National Weather Service meteorologists, not only are they working without pay in California because of the federal shutdown right now, but they are also being asked to do literally double or triple duty. So some of the offices in California are responsible not only for their primary responsibility, but they have to take over for the Sacramento office and the San Joaquin office at night when the staffing levels mean that there's nobody home. So there's physically nobody at the offices in the Central Valley now. Still, months later, it's October, we started talking about this in February, what it means is that the workload has dramatically increased for the people who remain at the other offices at a time when no one is getting a paycheck. And also included in the story are anecdotes from individual meteorologists saying that they feel personally compelled to stay in this role, this life-saving role, even though they aren't getting paid right now, but that ultimately they can't do that forever. And current indications are this shutdown will likely be the longest in American history and possibly go on even past Thanksgiving into the new year. We're going to start to lose people through the simple practical reality that most people can't just suddenly lose their income for multiple months unexpectedly and be expected to continue showing up for work. It's not that there isn't a sense of duty among these folks, it's that it's the simple practical reality of paying the bills. Can you pay your rent or your mortgage if your income just suddenly stopped, but you were expected to continue in your full-time job capacity? I mean, very few people could answer that question affirmatively. And that's what we're increasingly asking of public servants in life-saving roles. That includes the people flying into hurricanes or issuing your California flood forecast in real time. So I think that's really important context as this drags on, that we're going to start to lose things that we can't afford to lose, that we haven't lost yet, despite the best efforts of some folks who really want to dismantle these critical public utilities and institutions. But just out of the bare necessity of needing to earn an income to survive, some of these things are going to start to rapidly change and devolve moving forward. We're hearing about growing mass disruptions with air travel as air traffic controllers start to take on side gig jobs like driving for Uber or delivering food, because again, they're not getting paid. It's not great when people who in high-stress, life-saving roles are moonlighting as a delivery driver. Not because there's anything wrong with being a delivery driver, but because there's only so many hours in the day, and if you're still a full-time meteorologist, if you're still a full-time air traffic controller, and you're trying to earn your income by driving around in the middle of the night during the rest of your hours, well, I'm just going to leave it there. I'll leave it to the reader, or the listener in this case, to discern what might be a problem with that scenario, which is unfolding all around the country right now. Okay, so as promised, I'm going to do one more round of looking at questions, and then I will take a look one more time at the live satellite imagery, and then go from there. So still retaining around 300 people, which is great. If you want to stick around for the last 5 minutes, you'll stay here for the whole time. Yeah, Susan points out some low 80s predicted. even up in Marin County, which again, that is definitely warmer than usual for late October, early November. Not unprecedented, but certainly not a typical temperature for this time of year. By the way, I was in the Central Valley last week, and in Davis in particular for most of it, and it was not hot, but it was also very notably mild. And one thing I noticed personally was the prevalence of mosquitoes. I don't recall, and I have lived in Davis, I don't recall ever having experienced these swarms of late October mosquitoes in that part of the Central Valley, which I think this year has been facilitated partly by really mild overnight temperatures. There's certainly been no freezes yet, and it hasn't been very dry. There's been some moisture around, including some actual precipitation at early times of year, so I think there's been an unusual level of mosquito activity all across California. I'll maybe talk more about that at a later date, but it happens to be the same week that it was reported that for the first time in history, mosquitoes have been reported in the country of Iceland, where they previously were unable to survive due to coolness, but following a record warm spring there this year, apparently, even as we get into October in Iceland, they are continuing to survive on that high latitude island in the North Atlantic. So perhaps an even more exotic location than Yolo County. That's great to hear. CAL FIRE is doing a prescribed burn on my place on Wednesday. Comments, I don't know a name, but one person in the chat is having a CAL FIRE prescribed burn on their land this week, which is great. Another comment, there's about 60, so like around almost 5 dozen prescribed burns noted in Central and Northern California on Watch Duty just right now, which is great to see. And I'm really glad that functionality got integrated into Watch Duty, by the way. It's really nice that people can see a plume of smoke and go to Watch Duty and say, oh, that's actually not something to be concerned about. That's a prescribed fire. That's supposed to be there. It's actually maybe helping reduce the risk of a subsequent wildfire in that location when it inevitably occurs later on under more adverse conditions than you would ever see a prescribed burn conducted under. Okay, and as I promised, I want to close one more time by going back to Melissa. So I'll share the screen for just another minute or two before wrapping this session up. Let me make sure I'm sharing. Yes, I am sharing what I intend to share. So here's the update from Melissa. I'm going to refresh this to make sure it's live. In the hour and a half, it's been a long session. In the hour and a half I've been talking, unfortunately, we see some objective indication that Melissa, against the odds, has managed to strengthen even more. So notice even more purple, meaning even colder, higher cloud tops. And honestly, those colder cloud tops are now wrapping fully around the entire center again. So notice how the western quadrant was kind of a little bit less cold, more white than pink. Well, now notice in the most recent frame where it pauses at the end, there's now bright pink colors wrapping all the way around that eye. So the other thing that's notable is that there still is not an obvious northward component to its movement yet. But maybe in this last frame, a little bit of a wobble back toward the north. But again, this storm is expected to do a pretty wild right hook here, almost sooner rather than later. I would bet a significant amount of money that the National Hurricane Center is right. Even though it doesn't feel like it should do this, that is exactly what the wind currents suggest it's going to do. And I guarantee you I'm going to get some emails next week saying, this must be weather manipulation. Obviously the government weather machine made this do a hard right turn into Jamaica. And unfortunately, we're only the case that we could control the path of storms and ideally steer them around an island nation that's about to get the brunt of one of the strongest Atlantic hurricanes ever observed. But unfortunately, we do not have that power and almost certainly never will. So when this storm does this, be aware of the conspiracy theories that say that there's some nefarious or reason for it. The reason is essentially the laws of physics, the conservation of momentum, conservation of mass and energy, and the dynamics of fluid flow. And the fact that we were able to predict this in advance, assuming this happens as predicted, and again, there's never any 100% guarantee, but it is highly, highly likely that this storm is going to make an erratic, sudden shift toward the northeast and make landfall somewhere in the western half, and probably the western third with a slight westward jog of Jamaica before we all wake up in the western United States tomorrow morning. So unfortunately, I expect to see some pretty harrowing scenes, or perhaps not, and this is a case where no news is not good news. In fact, the less news there is from the western half of Jamaica, the worse it probably is tomorrow. You might well see images of major flooding in Kingston, but in general, a semi-manageable event, because it's more likely the power is going to stay on in the capital region, partly because it's the capital region, and also because it's not probably going to get the brunt of the Eyewall winds. But in the western half of the island, things are going to get really bad, and there will probably be wholesale destruction of the entire telecommunications and power grid, much like there was following Hurricane Maria in Puerto Rico. This storm, though, may make landfall at an even greater intensity than Maria did in Puerto Rico, and so this is really an enormous concern for this part of Jamaica, and then later eastern Cuba and the Bahamas thereafter. So I'll leave you with this image on screen, or I guess I'll stop sharing, switch over, and say good evening, and good luck to everyone in Jamaica who hopefully is in the safest place they can possibly get to right now, and hopefully there will need to be some form of international humanitarian response, likely in the wake of this, particularly in the western half of the island. So I really do hope that will be forthcoming, especially given all the colonial connections on the island and in the region. Hopefully other countries will step up to help, including the U.S., but we'll see what happens. I'll be following on this, as you might expect, on social media, on other channels, the text-based platforms. As always, if you want to see more of this in the future, subscribe to the channel and turn notifications on. Otherwise, I will talk to you all next time, and if you're in California, enjoy the relatively mild and non-extreme weather that you're going to have over the next couple of weeks. It is a blessing to have those calmer conditions. Allows you to spend some time outside or get things done, or just simply not have to think about the weather for a while, which is sometimes, as much of a weather geek as I am, it lets you get other stuff done. So hopefully that'll stick around for at least a little while in California. All right, I'll see you all later, and thanks for joining me on this extended special Weather and Climate Office Hour session this evening.